In this video, we're going to take you through the design and build of a triangulated four-link for our Barra-powered 45 series on an 80 series chassis.
We're going to show you how to design and build a rear suspension setup so your four-wheel drive can flex like this. I'll cover four-link design, material selection, and what it takes for a vehicle with a custom suspension setup like this to get registered in Australia. By the end of this episode, you're going to see the whole four-link setup built completely from scratch. Firstly though, let's get into why we chose a triangulated four-link for this build. Don't worry, it's not an entire episode in front of the whiteboard, but that's where we're starting for a quick explanation.
There are heaps of different suspension layouts which you may have heard of before, including independent, 3-link, 4-link, 5-link, Watts-link, and leaf springs to name a few. And they all have their pros and cons. For example, we all know leaf spring setups are fantastic for carrying a heap of load, but may not articulate as well as something like a triangulated four-link.
You can get leaf springs to flex, but you've also removed a bunch of leaves along the way, which means you've lost your load carrying capability as well, and these are the sorts of trade-offs I'm talking about.
And you can see over this side, we have a 5-link setup. Now it's called a 5-link setup because there's 5 links. We've got the lowers, the uppers, and then the 5th link, which runs diagonally across the car there. As the diff moves up and down with this setup, it's going to track laterally across the car, and it's going to pivot around this point here. Over on this side of the board, we have the triangulated 4-link. There are 4 links, as the name sort of entails. We've got 1, 2, 3, 4, so 2 uppers, 2 lowers. And it's actually that triangulation which stops the diff from moving side to side, which means we can do away with this 5th link like we have on the Panhard setup. The key point of this is that as the diff moves up and down through the travel, it's going to stay nice and centered, and we're about to explain why that's a good thing. And you're probably all thinking at this point, why don't we all just run a 4-link setup? We remove the link, we get more flex, which I'm about to explain. It'll be a simpler system that articulates better off-road. Well, it's just not that simple, and here's why. Let's start with the 5-link setup on this side of the board, and one of the big pros for this is that it's an OEM design, parts are readily available, comes on a GU, GQ, and 80 series, and if you need a part in the middle of nowhere, it's easier to get parts for this than a custom setup like our triangulated 4-link. Packaging is another huge advantage for this 5-link setup, and typically they come from factory with a shorter upper link, which means you can get a water tank and a fuel tank potentially in front of the diff, putting your weight closer to the center of gravity, which is way better for vehicle handling. Another advantage of this setup is when a bush wears out, there's still a Panhard bar running across the chassis, which means that the diff can't walk too far sideways. There's something always retaining it. To summarize, if you're doing ultra remote touring, you want less fuss on suspension setup, and you want to package some more fuel in there, this is probably the right setup for you. There are, however, some cons to this setup, and compared to our triangulated 4-link, there is less articulation. In saying that though, you've seen my personal car flexing pretty well, and I've taken it down to Tassie on climbers in the $1,000 track with very little fuss. There were a few instances where sure, I would have liked a little bit more flex, but it's set up as a tough tourer, so a 5-link setup is ideal for me at this point in time. Another one I forgot to mention, which I haven't written on the board for the cons of the Panhard, is a very lifted setup isn't very good. If you can imagine, the Panhard will be further down on the radius, and that means as you go through bump and droop, your axle is going to side shift more. With all of that in mind, we've opted to go for a triangulated 4-link on this build for a number of different reasons. Given this vehicle will be raced in a long course style winch challenge and wheeled hard on the tricky tracks, we're setting up the vehicle to be a high performance off-roader. Let's run through some of the pros for this setup. The triangulated 4-link typically provides better axle articulation compared to a traditional Panhard setup. This can help the vehicle put power down for your 500 kilowatt water meth injected Barra. The second point to this is that the triangulated 4-link controls lateral axle movement way more effectively than a Panhard bar, which can lead to improved handling and stability, especially during corner and off-camber situations. And the third point is that if the 4-links are set up right, there can be more adjustability in the setup. With the adjustment built into all the brackets, it means we're going to be able to adjust things like roll centers and anti-squat geometry relatively easy, and hopefully that means that the driver will have enough adjustability in the system so that he's happy. If you're doing hard wheeling and racing, then the triangulated 4-link is a setup you should consider on your build. There are definitely disadvantages of this setup as well, and the first one is that it's not standard, it's a custom setup. There aren't off-shelf components, and we'll have to be more mindful of the spares that we carry with us. There is also less packaging space as generally the upper links are longer, which means that if you're trying to package a fuel tank and water tanks in front of the diff, closer to the center of gravity, it's going to be much harder. There's also no fifth link in this one to retain your diff if the bushes are to wear out remotely, so make sure you're all over the maintenance. Obviously you can be running Heims in this setup as well, and we do on one end, but we're going to cover that later on in the video. It is worth noting that you could set up a 4-link to have shorter links and take up less packaging space, but you lose a lot of the advantages that I just described. There are definitely more pros and cons to both these setups, but I've picked out the ones relevant to our builds to keep this video nice and succinct. Let's jump into the specifics of our 4-link design. Firstly, let me just say there's no such thing as a perfect suspension system, otherwise we'd all be running the same thing and there wouldn't be any debate. Literally everything when it comes to suspension design is a trade-off. The goals of our 4-link design is to maximize the wheel travel without compromising the center of gravity, which has all sorts of off-road handling benefits. We've also built in a heap of adjustability into our system, and moving our upper links gives us plus or minus 20% squat, which is going to be awesome when we're tuning the vehicle off-road. We've also got a ton of adjustabilities in our shocks and links as well, which we'll explain later in the video. Packaging is a huge constraint when you're trying to achieve your perfect geometry, and there's a lot of limitations, including the width of the chassis, among other things, which has led to this overall design. Let's boil this down into a process. So first I got all my packaging constraints, then I put it into the link calculator off Crawlpedia, and then I validated everything and I adjusted my numbers and then packaging and geometry of the brackets to suit. And I iterated a bunch of times actually. It took me a couple of weeks to get numbers and packaging I was happy with. Once I had my hard points, then I did my detailed mechanical design. So what I'd suggest is get your geometry roughly right, put shapes in CAD, don't do sheet metal design brackets until you've got your hard points, and it'll save you a lot of time because I mucked around with these for ages before I went on to this step. Let's talk about the link calculator and the numbers. So to use the link calculator from Crawlpedia, you got to make a few assumptions. I took measurements off the CAD where all my hard points were, and then I was able to punch it into the calculator, which gives you numbers like anti-squat and roll centers. There's no such thing as perfect numbers. Depending on whether you're building a rock crawler, a winch truck, or a trophy truck, you're shooting for different numbers. The other thing to consider here is driver preference. While the vehicle may look like it's behaving better, drivers may prefer different setups to what the numbers say is best. There are a number of fantastic YouTube videos if you want to learn more about this. There are some really complicated concepts here. Busted Knuckle is a great example of this. I think he explains it really well, and I'd recommend you go check out his series. Now, luckily for me, when I was doing this 4-link design, the LCS shop truck has a similar design, which we were able to validate in the real world statically with a forklift before I jumped into the CAD design of this one. There are some big differences between both builds. We're trying to package coilovers and triples versus the LCS shop truck, which only has the coilovers. I validated my numbers and I validated my packaging in CAD as I'm able to cycle the suspension through its motions, which is really handy. To get a model like this absolutely does take a lot of time, and I've had a fair bit of experience on CAD to be able to do this sort of modeling.
I just want to say here, all of this work can be completed without using CAD, but for us to make these vehicles road legal, we need a model, and I'll talk about that later in the video. Also, ideally, because I've spent so much time iterating on the computer, checking potential clearance issues, I should save a lot of time on the build as it will fit perfectly together, just like a jigsaw, and I'll only have to do it once.
So there's a heap of design work here on both the mechanical and the dynamic design. The good news is there are high quality kits available from shops like Ramped Customs, who we've worked with in the past, and depending on what you want out of your project, this might be a really good option for you. Now let's talk about the benefits of this setup compared to a standard 80 series chassis. We're using an 80 series chassis over a Patrol for this build for a few reasons. Number one, the chassis rails are made from thicker steel and are inherently stronger. Number two, the rear coil hats don't require bracing on an 80 series chassis like they do on a Patrol. Number three, the front radius arm setup is worse from factory on a Patrol, and it's a pin mushroom bush style versus the 80 series, which is an I style bush. There are a heap of aftermarket products available to fix those particular flaws, but you still end up with a Patrol chassis which is weaker than an 80 series. We've already done a heap of frame modification to this build, which we covered in the first episode of the series, so make sure you go check out the link in the description below for that one. If you were to put a 3 to 4 inch lift on an 80 series chassis, with the shock body being longer, you'd compromise the up travel, And typically you have to put a longer hard bumper extension in there, which is about 60 to 70 mil long. So then the axle height is around negative 70 mil from where you can normally go. I've drawn a diagram here in blue of that. So this is the axle height here, and that would be the hard bump extension that you normally have to put in. I've drawn the modified chassis, which is the black dotted line. And basically what we've done is raise the height here by 75 mil. We're also able to obtain full up travel with this setup, and we've been able to delete the factory bump. If you add all this together, compared to an 80 series with a 3 to 4 inch lift, it means our axle can go up 195 or close to 200 mil, and we've got longer shocks, and we've been able to maintain the same center of gravity. Let's talk about this section for a second. So on a standard 80 series chassis, your arm generally pivots from this point here. Now, we've got a long arm setup on the build, which pivots from this point here. So under full bump, the arm will foul on the chassis right in there, which is why we've notched it out there. To do this notch up the top here is really nice, and we do get additional benefits, but really down here is where we're making most of our gains. What we basically managed to do is make an uncompromised system. Obviously there are compromises elsewhere, like with packaging. With all of that in mind, let's get into the manufacture of this system, and we've got to make this thing so I can validate it in the real world. Exciting day, spent a couple of weeks on the computer. Here are all our parts nested up, and we've got a 6mm sheet on the table, and we're about to press cut, and then Loz is going to fold them up for us. And what do you know, we'll have a 4-link. It's going to be easy as that, right? Yeah. First time every time.
Yeah, mate. What did you want that folded to, mate?
37.
That's exactly what it is. Whiskey? Let's put it in, mate.
This is what we're shooting for, a GU Patrol diff with a full-length truss and suspension brackets that should fit together just like a jigsaw. The existing brackets have already been cut off our diffs, and I'm just quickly going to run you through why we're using Patrol diffs over Landcruiser on the build.
We're using them for a number of reasons. Number one, we actually had them. These have come off Barra GU. The last time they were used was at Wild Dog a couple of years ago. So we're using what we have. It's the cheapest option. They're locked and they've got all the upgrades. Number two, GU diffs are inherently better in a lot of ways than 80 series diffs. The main reason for that is the front center is stronger than the 80 series. There is a difference in track width between the 80 series and the GU. So if you were to swap the front, then you kind of have to swap the rear. Now you could make up for that with difference in offsets. You'd be running mismatching wheels front to rear like a 79 series, and you don't want that. Some people will say upgrading to a GU rear diff is a downgrade because it's a semi-floater as opposed to an 80 series rear diff, which is a full floater. However, these have proven to be extremely strong and reliable, and you can see that on my car. It's done 40,000 Ks all over Australia, and I haven't had a problem with it at all. Now this is an H233 rear diff. On my particular build, I've gone the H260, and that's because it's got a higher live axle loading, which meant I could GVM upgrade the rear, which I did when I got it engineered. For this car though, it's a race car, and we're not going to be hauling dirt bike canopies or canopies around, so we don't need to do that. And this H233 does come with a little bit of advantage in the fact that the pumpkin isn't as low. Even though I've shaved my H260, the pumpkin still has a little bit better clearance. Because these are wider axles, we have better stability off-road. We're going to have a wider track width, which is really good for what we're trying to do with the vehicle. You could make the track width as wide as a GU by running bigger offset wheels, but that comes with its own downfalls, some of which include putting bigger loads through the kingpin bearings as well as the wheel bearings and the wheel studs. So by swapping to a wider axle, we've got a wider track width and we're not doing any unnecessary loading, which is really beneficial overall for the longevity of these diffs.
Just finished cutting and folding all of our suspension bracketry for both the axle side and the chassis side. So we've got a full width truss because we're going coilovers and triples on this, where we won't require coil hats, which allows us to run a full width truss, which is going to add a lot of strength to this axle. Welding a truss or any welding of this significant to an axle is a lot of heat. We've got to be quite careful to sequence our welds to avoid any distortion through the axle. There are a number of ways to go about this to keep the axle straight. We know that if we weld this over a long period of time, doing small welds and sequencing from side to side, that we can keep this diff straight without any hassles. The other thing that we're doing to make sure this is really strong is the truss is keywayed. So the top plate keyways into all these points here. We also have vertical supports which will keyway into the front and rear face of the truss. They also get stitch welded onto the top of the axle to ensure a really, really strong axle. Let's get welding.
Sorry, Lars, you got to do it again. That's like the most critical shot.
We're taking a quick break to tell you how to win a $14,000 Kincrome toolkit. This is the last week of the giveaway, so make sure you get your entries in.
Kincrome and I are teaming up to give away this Tool Armor 1053 piece toolkit. This is the exact same one that I've had in my shed for the past 2 years, and it's an awesome kit. So one lucky winner is going to take this home, and I can't wait to see it in someone else's shed. All you have to do is subscribe to the Kincrome YouTube channel, subscribe to the Design and Built channel, and buy a piece of Design and Built merchandise.
All right, we've just tacked the truss together and we've just done a test fit. It fits quite well. Remove that. We'll either just put a bolt in it or we'll weld up the hole because that will no longer be usable. We'll have to put another breather point in the back. Not allowed to video this part. Ah. So we've just thrown some crush tube in the upper link mounts. We have these brackets keywayed into the upper truss. It takes all the guesswork out. We don't have to measure. We need to make sure it's square, bolt it all together and it's ready to weld on. And it's also keywayed in the rear here. Just make note one more time that we're welding this on adequately enough so that we can put it in the vehicle, we can link it up and we can cycle the suspension. We're not welding it so good that we can't pull it apart because we want to treat all the metal. We want to go weld through primer on all the areas that we won't be able to access later, and we also want to do a lot of internal welding. If we do that now and then we need to pull it apart to make any changes, we're reasonably confident that won't be the case, but if it was the case, it would be throw the diff in the bin and start again. Because this is temporary, Make sure always to weld in a location where you can easily access with a grinder so we can chop it off with ease later if it needs changing.
Now the diff end brackets were tacked into place, we could get started on the chassis end link mounts. Here's the CAD of the upper and lower mount, and note the adjustability again in the upper bracket.
So here we have the rear diff and all the 4-link brackets. Now this has literally taken me a couple of weeks on the computer to get right, but the idea is that all that time spent on the computer should make it relatively easy to assemble. So this, for example, is profiled to the chassis, and that's using our 3D scan data of the chassis. So hopefully it's just going to slot in nicely. In general, the first time you do these sort of brackets, you probably do have to do a little bit of trimming, but that's all right. You update the DXF, and then second time it's pretty good. Sometimes it does take more than that, so don't get too disheartened if you're doing this stuff at home. These are our 7000 series aluminium arms. With all of this stuff here and another 3 arms, it should go together just like a jigsaw. So let's put the theory to the test and stick it on the car. Alrighty, we've just fabbed a diff support up for the front and the rear. So what this is going to allow us to do is set the diffs at ride height when we're welding on all the suspension bracketry. This is really important, setting up the 4-link at the rear. Now obviously you can do this without a chassis table and without these working off the ground, but it is very nice to have this chassis table as a reference because it allows us to keep everything perfectly square. Now later we'll be able to put additional bracketry into here to put it in a full bump, which is pretty cool, and we'll be able to articulate our suspension system on the table. This now should be at the ride height. Blaze these all off and then put the diff in. Alrighty, so George and I have just spent a bit of time getting the diff centered, and we've also set our pinion angle at 4 degrees, which is the same as our powertrain. The pinion angle different to the powertrain, it's going to cause premature wear on the uni joints, so really important to get them both in sync. That's about it. So what we're going to do for now is just put a tack at the back just to make sure that this stays in position while we're putting our 4-link bracketry on.
With the diff in, we could now start getting our links ready for install.
Time to talk about aluminium links. We're using the 7075 T6 aluminium for our suspension linkages. Now, for anyone unaware, the 7075 T6 is a high-strength alloy which gets tempered to reduce brittleness and enhance toughness. Tempering is a heat treatment process used to improve its mechanical properties, which involves heating a material up to a specific temperature below its melting point, holding it at that temperature for a certain period, and then cooling it down. What we end up with is a lighter, stronger link that's able to bend more without permanent deformation compared to a steel link. It's really important to remember this because compared to a regular aluminium you're used to seeing on a car like 5000 series, it is extremely different. To explain all this properly, it probably deserves its own video, some FEA and empirical testing. So let me know if you'd like to see something like that in the comments. It's definitely more engineering explained than I normally do. Apart from the material properties, there are some other reasons why we go with aluminium as well. It is easy to work with. You just measure the length and get this custom machined. There's no welding or heat treating required. They're also really nice and light. These are really adjustable. It's a left hand and a right hand thread. So all you need to do is spin this middle bar and you can extend or shorten the length. All right, up to a really exciting part now. We get to put the links and bracketry in. George has kindly set the eye-to-eye distance exactly the same like we have on CAD. And now the next step is we're gonna put these in, locate the bracketry, and then we can weld off or tack it on for now. But have a look at this. So this will just slot in here. This is the correct length. This is in the correct position with the correct pinion angle. And now it's as simple as clamping that on and tacking it off. Man, look at that. Jeez, it's exciting. It's like weeks and weeks on the computer to get to this. I mean, it seems simple, right? But like, not the case, not the case. Not going anywhere. Not going anywhere. Alrighty, we're just under the car now and we've got these lower link brackets tacked on, the upper ones as well. And you can see we now have a 4-link, which is super, super exciting. So these brackets, really happy with them. They triangulate back to the chassis. Now they do underhang, but to get all the geometry we wanted, that was necessary. But this ramp angle here means that if we get hung up on a rock or something like that, it should slide over pretty easily. But yeah, nice and triangulated, nice and strong to the chassis. We've got a heap of cutouts in here for cleaning as well, so we'll be able to get the high pressure hose in there. We'll put a nice gusset up in there eventually, I reckon. It'd be pretty cool, but it's looking very race car. So next step is to tack on the shock mounts, and I've been working on them in the background for a couple of weeks. We've got to try and package some triples and a coilover as well.
The chassis rails had a huge part to play with the position of these shock mounts. Through articulation, the spring on the coilover, which isn't modelled here, gets super close to touching the chassis. And given where they have to be mounted on the diff, a full-length truss makes a lot of sense.
Got all our pieces, time to stick it all together. Get one. Now at a point where we can mount our springs and shocks. So let's talk about the setup that we're going to run on this build briefly. This is probably the setup you're most familiar with. This is obviously a shock absorber and this is a coil spring. A spring damper setup is pretty standard and they work really well. They're inexpensive, easy to work on and easy to swap out parts, generally pretty lightweight as well. There is less adjustability in the system overall. We're looking for more travel in this build, so if you put longer shocks in a standard chassis, the top of the shocks stay at the same point, meaning you're probably increasing the ride height and reducing the up travel, which decreases stability, especially through compression. Okay, so that wraps up spring and shock. For this build, we're gonna be using a coilover, which basically combines the spring and the shock and puts it into one nice, tidily packaged unit. They offer more adjustability, more travel, but like the rest of the build, they're just not standard, which isn't ideal for spare parts. We've also chosen a triple bypass shock for this build as well. These are the duck's nuts when it comes to dampening control. Each one of these bypass tubes allows the oil to pass around the piston as it moves up the stroke. This means we have compression adjustment throughout the stroke, which is amazing. They're super easy to tune as well. All you have to do is turn these Allen key heads, which we should be able to do when we're out on the tracks. So adjusting these is going to change the behavior of the shock and it's easy to do on the fly as opposed to a coilover, which may require revalving. These are purely just a shock, so you've either got to run a spring or a coilover, and we've opted to go with a coilover for all these reasons we've just outlined. By combining the coilover and the bypass shock, the bottom line is we're not compromising on ride height, bump height, or stability, and we'll have the maximum adjustability in our system, which is going to be really handy when we go racing.
We're using King 2.5 inch triples and coilovers with 12 inches of travel at the front and 14 inches on the rear. I've just taped them up here so I don't scratch them on the mock-up.
So I've tacked this bar in place now, and basically the shocks are set up in the correct geometry. So what we're going to do is actually build the top mount. As much as I'd like to say job done, these are only temporary, and we're going to do a piece of tube work. Then we'll do some plasma cut brackets to tie it all in nicely.
Kind of helped me finish off the bar work for the top mount of the shocks, and unfortunately I didn't get the footage as my memory card went corrupt. There's a whole video on my channel on the bar work for this build, so make sure you check it out if you haven't already.
What we're going to do now is just do some final bracket. When we tacked these in, we made sure that the bars were still in place, so these holes are still in exactly the same position. Then what we're going to do now is tack the other side with the final bracket design. So the shock mounts are tied to the guards, which are welded to the chassis. They're also tied back down to that bar there, and we'll probably do some additional bracing later on in the piece once everything's mounted up. Now we've got one side tacked on, we can cut these temporary tabs off and then tack the other side on.
And just like that, the shocks are now tacked into place. Don't go anywhere though, because I'm going to tell you how to get a build like this road legal in Australia.
Throughout the mechanical design of all our bracketry, we're always considering load paths. So you can imagine when the shock hits a bump on an angle like this, all the load is going to go up through that way. And basically what that's going to do, as it travels up through this bracket, we've got to make sure that there's material there. And obviously these shocks are going to go side to side in articulation as well. So you've got to make sure that there's material in the relevant places. Now it seems pretty simple, but it's really important when you're designing your bracketry. This goes into a corner, which is then sort of triangulated back down into these guards. It's always good practice to put these tubes into nodes if you can. Sometimes it's just not possible. Let's talk about engineering. This is probably my most commonly asked question. What does it take to get a build like this on the road and legal in Australia? The reason I don't say too much about this is the regulations do vary state to state. And while I know a lot about the Victorian regulations, I'm not across the other states. Each state, to my knowledge, follows VSP 14, and if you're planning on a big build or modification, I'd suggest getting familiar with those regulations. You'll also have to engage a relevant engineer. In Victoria, they're called VAS engineers, and you can find a list on the VicRoads website which show what they're able to sign off on as well. To get more significant modifications like this 4-link engineered in Victoria, I have to do the stress analysis using finite element analysis software on the computer. Luckily, I'm a registered mechanical engineer in Australia, and to become one, I've had to do my master's degree in mechanical engineering and had relevant industry experience, which was a lot of effort, but it means that the VAS engineer is happy for me to do the analysis work in-house and make this build road legal. There's probably a month worth of work to do in the back end of this build to get the relevant FEA reports ready so this vehicle can be registered. So it's a lot of work that you won't see me do on camera. But in my opinion, it's really important for these cars to be street legal so we can get maximum use from them.
While the rear end may look complete, we've still got to package hydro bumps and sway bars in there, and we'll cover this in a future, probably standalone episode.
Don't forget to enter the Kincrome 1043 piece toolkit giveaway. All you need to do is buy a piece of merch. There's only a week left, and I can't wait to give a 14K toolkit away to one of you lucky viewers. Thank you so much for the support, and if you'd like to see more content like this, I'd ask you to subscribe, as we've got some pretty cool projects coming up. Next up, we're working on the front end, and we get to start packaging everything for this build. Cheers for watching.